Welcome back, and in this video we're going to talk about scientific and standard notation. And one of the biggest numbers you probably have seen in chemistry obviously is the mole, 6.02 times 10 to the 23rd, which is the number of particles, molecules, formula units that it would be in a mole of any substance. And that is written in scientific notation. Now, a lot of times scientific notation is used to reduce the amount of space that is present or needed, and therefore you're not going to have this long string of numbers in order to express what you're worrying about. And unfortunately, you can usually only use a cheap dollar store calculator on the Regents exam. Now, during the year, you can probably use a graphing calculator or use, a computer program, put in brackets, put in, parentheses and exponential values and figures. But unfortunately, with these lovely calculators, you usually can't do that. So you need to be able to know how to convert those numbers. Now, just a little reminder, any positive number, so for example, 10 to the 23, that means I'm moving to the right 23 places. And obviously that would be the decimals moving to the right. So 6.02, I would move it 1, 2, and I would move it 23 places to the right. Let's say, for example, I have something to the -4th. Any negative number means to the left 4 places. So when we're talking about small numbers, we might see things that are going to be measured in, micrograms or something, and we maybe easier want to have what looks like a whole number, but we want to express it mathematically in a smaller amount. So for example, I might have 3 times 10 to the -4th grams, and we would need to be able to express that. So these obviously are scientific notation, but taking that scientific notation, we can put it into standard notation. All we have to do is move our decimal over. So if my decimal were here, I would move it 1, 2, 3, 4 places, and obviously I would have to fill in zeros. So 0.0003 is the same as 3 times 10 to the -4th. Okay, both those numbers really mean the same thing. And it depends on how you're going to do this, depends on what math you're going to be doing, but you need to be able to convert back and forth. Now, sometimes you have a number that is a little bit differently written, or maybe you're doing some multiplication or division and you're playing around with your exponents. Remember, if you're going to multiply exponents, you add the exponents. If you divide exponents, you subtract the exponents. And so let's say you come up with an answer, and let's say your final answer is 86 times 10 to the 5th. 86 isn't written in proper scientific notation, because in proper scientific notation, remember, your number has to be between 1 and 9.9. So I know 10 to the 5th means I'm going to take and move from here 5 places to the right, or 5 times, but I actually have to move it back. I really have to be here instead, because it has to be somewhere in between. 8.6 is an additional place over, so 8.6 times 10, and instead of going 5 places now I would have to go 6 places. So we have to add 1 to our exponent. So 8.6 times 10 to the 6th. So hopefully you've done a lot more of this in math class. If not, be sure to go back to your math teacher and talk to them about this. We touch base on it minimally in chemistry, but it is something that you need to understand. If you look at the front page of your chemistry reference table, table C has all of your metric scales, 10 to the 3rd, 10 to the 2nd, so on and so forth, or -1, -3, all the way down to 10 to the -12th when it gets into micro, nano, and pico. So when we're looking at things that are really small, especially the size of an atom is extremely small, but if we think about a mole is extremely large. So we have numbers or exponents that could be very largely positive and exponents that can be very largely negative. So make sure you are understanding how to go back and forth between scientific and standard. Your scientific, again, always has something that is 10 raised times 10 to the something, where your standard notation is just numbers and decimals and does not have any factors of 10 raised to any power. All right, hopefully you found value in this, and I look forward to hearing about your successes in your science classes. Thanks.